To study exterior lighting using the Scanline Renderer, first ensure that your custom UI initial settings setup is set to max. This is the default setup when you install and run 3ds Max. The UI color scheme is optional and left to your discretion. When you render a daytime exterior scene, there are usually two light sources to consider. The first is the sun and is considered the main light source. The second is the ambient light or daylight. The sun can be considered as a point light since it emanates energy in all directions. However, given the sun's considerable distance to Earth, the sunlight that reaches us is cast in virtually parallel rays. Placing a point light 150 million kilometers from the center of your 3D scene is not a practical approach. It is easier to use a direct light to simulate the sun, since direct lights cast rays in parallel mode. You can position the light to simulate the angle from which the sun is affecting the scene. It is good practice to enable ray trace shadows to simulate the sun, since sun shadows are often crisp on a clear day. Make sure Use Global Settings is disabled if you are planning to later use other shadow types to simulate global illumination. To control the intensity of the sun, you can adjust the light's multiplier value. Directional parameters are also important, mostly to enable overshoot when simulating the sun. Failure to do so restricts the sun illumination to the fall-off field value. Still, you need to ensure that the fall-off field value is large enough. Shadows are not calculated outside this range. In addition to a light source simulating the sun, you need other lights to simulate ambient lighting created by light bouncing off all scene surfaces. Trying to strategically place a few light sources here and there may yield fast results, but it usually looks unnatural. To simulate better daylight, you can create a light dome. A light dome is a set of instance lights placed in a dome-like pattern. They usually cast soft shadows because their intensity is not very high. To manually create a light dome, you first create a target spotlight, setting its multiplier value to a fairly low value, and its shadow type to shadow map. You can then adjust direction parameters to overshoot, with a fairly large fall-off to encompass the scene. Move the light upwards so that it is slightly above the ground. Next, you need to instance this spotlight around the center of the scene. You can use a working pivot to do so, or if your scene is centered, use the world coordinate system as a base. Using the Array tool, instance the spotlight 12 times based on a 30-degree rotation in Z. It is critical you use instance, not copy, since the light dome is meant to work as a single light. The preview button lets you see the results before you commit to them. After the first ring is created, you can use Shift-Move to create a second, higher ring. Scale the second level of lights to the center point to close the top of the dome slightly. Since you initially used the target spotlight, the scaled spots still point to their targets, which is the center of the scene. Create a third level of lights and adjust it to complete the dome. Render the scene again. The results are much improved. You can adjust the intensity of the light dome by changing the multiplier value on any of its instance target spotlights. A light dome is a quick, albeit not physically accurate way to simulate daylight. Another method to simulate daylight global illumination is to use the skylight object. On its own, it floods the scene with ambient light and produces a very unnatural render. To use skylight efficiently with scanline rendering, you need to use it in combination with the light tracer engine. Light tracer simulates daylight in a dome pattern, but also accounts for the bouncing of light rays. Decrease the number of raised samples to start with the low-quality simulation. You can always increase this value later. Light tracer also lets you use a color bleed factor, so that reflected light carries with it color information from other surfaces. For improved results, increase the number of bounces to 2 or 3. This increases the bouncing of light rays and helps with the simulation. Render time is now longer, but the render is better and more accurate. Notice the green color bleed between the floor and the body of the car. If the render appears too grainy, increase the number of rays sample for a better simulation. Increasing filter size helps remove noise artifact by introducing an amount of blur. Do not use too high a number or you will lose detail.